Like you talking about
Oh, my ear. Who watches Futurama? Anybody? Futurama fans?
Yeah.
That's what my hair like.
I see it, you little.
I don't watch too much anymore. I used to watch all the time.
Right here.
Now, boy, better be on my team to play basketball.
It's pretty funny. I'm not gonna have a head.
Just because you bullied me, I'm
Yeah,
just
okay, here we go.
You don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents,
All right.
and at an average of 2.25% interest over a period of 1,000 years, that comes to dollars.
Alright, watch it one more time.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents,
All right.
and at an average of 2.25% interest over a period of 1,000 years, that comes to dollars.
You can pause it, close it out.
We don't seem to have your,
I don't understand the purpose.
bro? Because he has to pay. You have to pay money, a whole bunch of money. It's because of
He ain't gonna
after
pay it though.
1,000 years.
No, that's his bank account, and so if you have like a savings account, the bank will pay you a little bit of interest for them keeping your money. Because what the bank does, they take everybody's savings account because they know they're not gonna touch it, and they go invest it
Also, he
on
That's how much money he
the
has?
stock market, and they make money by using your money. How about that, huh?
I thought that.
And they make good interest rates, and they only pay you like, well, what's interest rates today on a savings account? Nothing.
0.8, 0.6.
Yeah, like not even a percent.
I thought they had. I thought they took tax money.
And like maybe 20 years ago, 4 or 5% maybe?
When they're
2%, 2 or 3%. So it's really gone down.
He.
So the premise of this is obviously,
Shut up. I mean, maybe. Yeah.
so obviously he forgot about his bank account, and now he's going back to see what he has. So he had a balance of 93%, and they're giving him. Did you guys catch how much their interest rate? They said. Uh-oh. No one.
2.25.
Yep, it was 2.25.
Oh, that?
Okay. So that's not. I mean, that's pretty good today, but I mean it's only 2%, right? Okay. And you only had 93%, 93 cents. So on the back of your bell work, I want you to write down a couple of guesses.
Who is it?
I want you to guess. Tell me how much you think he has in his bank account today.
It was 1,000 years.
Yeah, it's been 1,000 years.
You did that yesterday.
Put your on your back of your bell.
Thank you.
Bro, caught me on guard yesterday.
Mr. You said they gave
He
him so
tried to
much?
give me. He took a picture yesterday, couldn't believe it.
Yeah.
No, he didn't.
So
He tried
the
to
balance is going to go up. They're giving him a little. They're giving him 2%
And what he just had?
every year.
Oh, every year.
Yeah. Yep. Just put one guess what you think, and after you put that guess, tell me a guess that you know for sure is too high, and then tell me a guess that you know for sure is too low.
Wait, so tell you a guess, tell you one is too high, and tell you one is too for you?
Yeah, 3 guesses, pretty much. Tell me what you think his bank account balance is after 1,000 years. With a beginning, an initial value of 93 cents, and then 2% interest every year. And after your guess, then tell me, where's Robert? Can you get it up? Put these guesses down? Okay. Yes, sir. Okay.
How do you do that?
That's what you think?
How you
I
doing?
like that. Calculator on that carrier, that's nice. Huh? I don't,
I wanted to
so
know.
yeah, how do you do a guess?
No, I want to know how he did on the calculator.
He was doing more of an educated guess, right? Because you think you might know something about something, so you kind of apply maybe what you know. But I'm just asking for a guess. I mean, yeah, if you think you can know.
2%. I don't know nothing about percent.
2% no? Oh, you can't have milk, can you?
Not really. I just did anyway. No, I think rice milk and almond milk. I do almond and rice milk.
See, there's those almonds again. Can you believe it? Okay.
I wish I had all.
Mine. Can you log us in, please? All right. Go ahead and slide that underneath your SAS 4. Focus up on your SAS 4, and we'll get started today.
Well, he wouldn't have flipped over that. We had $60.
Can you take us to
Makes me want to cook that thing.
modeling? Growth, modeling. Yep. Okay. Great. So we'll get back to Fry and his bank account here after a while. Let's walk through an example here of exponential growth, kind of in the real world. Okay. What we've looked at so far is like when things double or triple. On the last couple examples over the last couple days, but usually things don't go that fast. Okay, that would be just unfeasible for that to happen. Usually they grow at a slower rate. Okay, so we have this high school here that starts with 1,000 students, and they've looked at data over the last 20, 30 years, and they're seeing that hey, our school is growing at about 1.5%. Okay, so that's kind of comparable to Fry's 2.25% bank account. And so now they're going to use that data to kind of predict where their school is going as far as the population goes. How many students are they going to have in the future? They need this information. Why do you guys think they need this information? They're just not doing this math just for fun. Why do you think people have these stats and they do this stuff? So first, let's take ourselves back to 2008. So we're in 2008 right now. All these numbers right here are the future.
Okay.
So it's kind of old data, but usually it is because it takes a while for data to get gathered and then researched and all the stats done on it. Yes, Serena. SAS 4. Okay. Thank you. Or what? 495 to 502.
So we got 2 packages.
We have 1 packet. Extra credit is SAS 3.
The whole thing.
Guys, we go in order in these books. So whatever pack we did the last day, SAS 2, and then I said 3 was going to be extra credit. So 4 should be the next sequence. Should be the next pages. You get there. So you should have a gap. You should see a page that says like 200 something, and then your next page is going to say 400 something. So that's where SAS 4 starts. If you've ripped out every packet and are up to date. Okay. Once again, the stapler is broken, or is it fixed now? Mrs. Pfeiffer, is the stapler broken? Or still fixed? Okay. It will be coming around, so you start seeing it, it's coming to you.
I think Bianca's gonna bring her. She said she would. But all they do is.
Okay, so a couple seconds. Some of you guys are still looking that out. Ben, been using it. Sign of learning right there.
Yeah.
Okay, so you guys want to follow along on the first page on number 1, filling out this chart. So we have 1,000 students the first year, okay? Or at the very beginning, the initial amount. After the first year, we're going to take 1,000 times 1.015. Anybody tell me why it's 0.015? When we said the percentage of growth was 1.5%. Okay. So they say the growth rate is 1.5%. That's how much the student population is growing. But down here, they're multiplying by 1.015. Why is it 0.015 instead of 1.5?
What,
Oh,
because,
cause it's a 1,000.
Okay.
oh,
Serena, what do you think?
because they add on, they like, they can do this
Yeah.
and add on.
What's when you have a percentage and you want it in decimal form, how do you get that? You guys remember?
Yeah, you move the decimal.
Move it how many places and which way? 2 to the left, right?
If you,
Because percentage is like out of 100, right? Okay. So yeah. The decimal one was right here, 1.5, but we moved it 2 places. But what about that 1? Why is that 1 there? Because why don't we just multiply it by 0.015, right? That's the percentage growth, right? Grab your calculators and do that. Take 1,000 times 0.015.
It's
15, 15. Or 150.
You gotta have that one.
15?
Even at the 1,000.
So that's how many, as we can see from the graph, we can see that, okay, we're adding 15, that makes sense. That's that 1.5% growth.
Oh, so that's why you add the 1, so you can get the 1,000.
Yeah, good. That 1 helps keep the initial amount, because 1 times 1,000 is 1,000, right? Because what we could do, we could break this apart and kind of use the distributive property. Don't want to get into that. I think you guys understand that that 1 stands for keeping that initial amount, and then your 0.015 gives you that growth. Good. And so the second year, okay, the same thing. We're going to take that growth rate, 1.015, and right here, and we're going to multiply it by 1015. Well, we can represent 1015 as this right here, this parentheses, right? Because 1015 was this, right, on this row? So it's just kind of using substitution. Instead of saying 1015, instead of putting in the previous year and calculating it, we're going to use this, the process part, for the previous year. Okay? You get 1030. So right now it's kind of looking like linear growth, right? 15 and 15. Well, let's look at year 3. Okay? What do you guys notice about the process? Just this column right here. What do you guys notice from year to year? What is happening? We're adding 1.015?
Comes in another one.
Yeah, Richard, you said multiply. Did you say multiply? I couldn't hear it. Added to the multiplication. Good. You're adding one more multiple of that constant multiplier, the 1.015. Let's see what that is.
Man, we got it right on that?
You sure did. Doesn't do good. Okay, so now they gained 16 students this year. Okay, so that's a little bit more than 15. And hopefully we can see this pattern start to develop. That each year, we're multiplying the last year by the 1.015. Well, instead of always calculating that year and then getting the next year, we can just see this pattern starting to develop of that 1.015. That's our constant multiplier. And so from 2008 to 2012, we're in the 4th year, and we have 4 multiples of 1.015 getting multiplied to our initial amount, 1,000. Okay, go ahead and put that in your calculator, see what you get. See if you guys. 1.015 to the 4th times 1,000. Who are you cutting in half? You cut someone in half? We're talking about people here. You said 0.36.
This is 1,000.
Round it to the nearest number.
Yeah, 1,061.
1,061. Good. Richie got scared. What? No. So always pay attention to these word problems, these application problems. You know, we can't have half of a person, 0.36 of a person. So round appropriately. Did everybody get that? 1,061? Shake your head if you did not get that. Let's correct that right now. If you did not get 1,061. Need a calculator, Trenton? Got you one? Yeah, we'll need it. We're gonna do a few more things on it today. Yep. Okay, let's do one more, and then I think we have the pattern. So what do you guys think is gonna be right here on the process part? Can you guys shortcut that now instead of writing all this out? What? Okay. Does anybody disagree? Malachi said 1.015 to the 5th times 1,000? Is that what he said?
Yeah.
Okay. Any disagreements on that?
No.
Let's check. Yeah, sure is.
Wait, so we don't have to write all that, just write 1.0?
Yeah. If you understand the process.
Dang, no, I messed up on this.
So go ahead and put that one in your calculator. It'll be the last one for this guy.
Yeah, I messed up.
So 1.015 to the 5th times 1,000.
I didn't have another one of those.
Oh, yeah. So you need five of them on that row. But the main idea is to understand that, hey, copy this, so we can shortcut that with exponents. As soon as you guys understand that,
Like, do I really gotta put this down?
that's what I'm saying. Once you guys understand this pattern, and that's a constant multiplier, you can use what you know about exponents. That's why we did topic 14 on exponents, laws of exponents, before we went on to this stuff. Because now we're going to apply kind of some laws of exponents.
1,077?
Oh, let's go check. Anybody else get 1,077?
I ain't do yet.
Cody, waiting on you?
Yeah.
Good?
Oh, yeah.
Okay, you guys can go fill in the rest
Where my friend go?
and see.
What?
And
He gone.
pay attention, because sometimes they jump. We didn't go to 2014, we skipped 5 years. And then we skipped 10 more years. Okay?
You said, yeah. Is he gonna come back?
Who?
Go Sweat?
Where'd he go? Okay, once you get done with that, let's see if we can come up with an equation. Instead of doing a table, right? Tables are lengthy and tiresome and redundant. Let's get a function rule, so that way we can put any value x in, any year, down the road, and we can figure out what we think the population is going to be of this school. So help me out, whenever you guys are ready. Yes, sir. Number 2 on your paper, and then up on the board, same thing. Give everybody a second to think about it. So you're just think about it just for a second. Let everybody have a chance to look at it. Okay, what is in the first one?
The first one
Why? Good. Raise your hand for me. Do teamwork here.
is what?
Chloe. 1,000. Teamwork, Richie.
1.0. Yeah.
1.015. Someone else, hopefully, maybe? Otherwise, I might get back to you. Okay, Malachi. Or Cody.
X.
X.
She was raising her hand the whole time.
Who?
Just say her name.
Serena, she got started. She did the first one. I wanted everybody to get in on it. Good, that's it.
Everybody.
That's good, that's good, that's good. Few notes to write down.